Hello everyone, this is Phys103. This is nuclear physics, and in this lesson we are going to learn about the last type of radioactive decay, which is the gamma decay. So the nucleus, just like what we have learned from quantum mechanics, the nucleus also has quantized energies. Similar to that of when the electron, for example, you have an electron here, has a quantized energy corresponding inside the atom. So the nucleus, its quantized energy is much higher compared to the quantized energies of electrons. Particularly, it's in the range of mega electron volts. So if it has quantized energies, it also must have a sort of ground state. So when in a stable atom, we can say that the nucleus is in its ground state. But when an nucleus gets excited by either a transmutation inside, so we have learned previously in beta decay that a proton may be converted to a neutron and the neutron may be converted to a proton. So it can be the nucleus can be excited by either means of transmutation or bombardment of energetic particles. And yeah, so it will be excited when you do these two things in the nucleus. So you can think of the nucleus as, so they have protons and neutrons inside, and moreover inside the nucleus they also have energy levels. So the energy levels are also quantized. So when they are quantized, or when they are in a excited state, they would normally want to go back to their ground state and release some form of energy. So that form of energy, since it is quantized into this range mega electron volts, that form of energy is in the form of light in mega electron volts. So light in mega electron volts is called gamma rays. So that's why in gamma decay you will get you need first a excited nucleus. So let's take the case, or let's prepare a excited nucleus by a beta minus decay. So for example, carbon 14, so this should be 6. Carbon 14 decays into its nucleus decays into a nitrogen nucleus plus some electron and plus some antineutrino. So this is beta minus decay. Now we haven't discussed in beta decay that this nitrogen nucleus is actually excited. So this nitrogen nucleus will further undergo another decay, which is the gamma decay. So when this excited nitrogen wants to go back to its ground state, it will, of course, it will be the same element, but it will release a gamma ray. So this is a gamma decay. You have the same element, same element with the excited nucleus, and when the nucleus transitions from excited to ground state, it releases a gamma radiation in the process. So gamma radiation is a very energetic particle, or very energetic light. So in the case, comparing it with the three types of radiation, so for example, we have our alpha particle. So alpha particles can be blocked by a sheet of paper. For beta particles, they can pass through a sheet of paper. For gamma particles, of course, they can pass through a sheet of paper. Okay, so beta particles, even though they can pass through a sheet of paper, they cannot pass through concrete or wood. So concrete or wood is enough to block beta particles, but gamma particles, they can even penetrate wood or concrete. So this is how energetic gamma particles are. And gamma particles cannot pass through lead. So for example, you have a block of lead here. So the only way to stop a gamma radiation from entering some area is to block it with lead. So that's why a lot of workers in nuclear power plants have their suits be coated with lead, so that gamma particles or gamma radiation cannot penetrate through their bodies and cause some genetic mutations and some other complications. So that's the three types of nuclear decay. So you have alpha decay, you have beta decay, and gamma decay.